Welcome to Elementary Probability Theory. In this presentation, we will explore the fundamental concepts of probability. We will cover a range of topics including introduction to probability, interpretations of probability, addition and multiplication rules, fundamental rules of counting, and permutations and combinations. Probability is a term we use frequently in our daily lives. For instance, a doctor might say there's a 50-50 chance of surviving an operation, or another might say there's a 95% chance of having a particular disease. Probability is the chance that some event will happen. It is a numerical value that measures the likelihood of an event occurring, calculated as the ratio of favorable outcomes to the total number of possible outcomes. An outcome is one possible result of a probability event. The sample space is the list of all possible outcomes. Simple events are specific outcomes, and events are collections of one or more simple events. Probability theory helps us manage uncertainty by quantifying the likelihood of outcomes, ranging from 0 to 1. It allows us to make informed statements about uncertainty and apply various methods to measure probabilities. When an event is denoted as A, its probability is represented by PA. Independent events do not influence each other, equally likely outcomes have the same chance of occurring, and counting rules help determine the number of possible outcomes. Complementary events are pairs where one event's occurrence means the other cannot occur. The sum of the probabilities of an event and its complement is always 1. For example, if the probability of rain is 0.3, the probability of no rain is 0.7. The probability of an event A, plus the probability of all other outcomes, equals 1. Mutually exclusive events cannot occur at the same time, while non-mutually exclusive events can. Classical probability assumes all outcomes in a sample space are equally likely. It is calculated by dividing the number of favorable outcomes by the total number of possible outcomes. For example, rolling a fair 6-sided die has a probability of 1/6 for each face. Empirical probability is determined based on observation and actual experience. For example, if you flip a coin 100 times and it lands on heads 55 times, the empirical probability of getting heads is 0.55. To find the probability of flipping a tail, divide the number of favorable outcomes by the number of possible outcomes. The probability is 1 out of 2, or 50%. To find the probability of rolling a 4, divide the number of favorable outcomes by the number of possible outcomes. The probability is 1 out of 6. To find the probability of rolling an even number, divide the number of favorable outcomes by the number of possible outcomes. The probability is 3 out of 6, or 50%. To find the probability of spinning green, divide the number of favorable outcomes by the number of possible outcomes. The probability is 1 out of 4, or 25%. Calculate the probability of each independent event: black, 1, odd, and prime. Use the given spinner and prime number list to determine each probability. Here are the answers. The probability of black is 4/8, 1 is 1/8, odd is 1/2, and prime is 1/2. These calculations help us understand the likelihood of each event. In a sample of 50 people, we have different blood types. We can set up a frequency distribution and find the probability of having each blood type, such as type O, type A or B, neither type A nor O, and not having type AB. Using the frequency distribution, we calculate the probabilities. Type O is 21/50ths, type A or B is 27/50ths, neither A nor O is 7/50ths, and not AB is 48/50ths. These calculations show the likelihood of each blood type in the sample. Mutually exclusive events cannot occur at the same time. For example, getting an odd number and an even number on a dice roll are mutually exclusive. Determine if the given events are mutually exclusive or not. When two events, A and B, are mutually exclusive, it means they cannot happen at the same time. There is no overlap between the events. A box contains 3 glazed donuts, 4 jelly donuts, and 5 chocolate donuts. If a person selects a donut at random, the probability that it is either a glazed donut or a chocolate donut is calculated by adding the probabilities of each event. When events A and B are non-mutually exclusive, it means that both events can occur simultaneously. There is some overlap between the events. In a hospital unit, there are 8 nurses and 5 physicians. 7 nurses and 3 physicians are females. If a staff person is selected, the probability that the subject is a nurse or a male is calculated by adding the probabilities of each event and subtracting the overlap. Two events are considered to be independent if the occurrence of one event does not affect the occurrence of the other. The probability of both occurring together is the product of their individual probabilities. A coin is flipped and a die is rolled. The probability of getting a head on the coin and a 4 on the die is calculated by multiplying the probabilities of each event. When the outcome or occurrence of the first event affects the outcome or occurrence of the second event, the events are said to be dependent. A person owns a collection of 30 CDs, of which 5 are country music. If 2 CDs are selected at random, the probability that both are country music is calculated by considering the dependency between the events. The conditional probability of an event B in relationship to an event A is defined as the probability that event B occurs after event A has already occurred. A recent survey asked 100 people if they thought women in the armed forces should be permitted to participate in combat. The results of the survey are shown, and probabilities are calculated based on the responses. The solution involves calculating the probability of specific responses based on the given data, using the conditional probability formula. The fundamental counting rule states that if there are m ways to perform one action and n ways to perform a second action, then the total number of ways to perform both actions in sequence is the product of the number of ways to perform each action. A coin is tossed and a die is rolled. The number of outcomes for the sequence of events is calculated by multiplying the number of possibilities for each event. There are 4 blood types, A, B, AB, and O. Each can be further classified into Rh plus and Rh. The number of different ways a blood donor can have their blood labeled is calculated by considering all possible combinations. The digits 0, 1, 2, 3, and 4 are used in a 4-digit university ID. The number of different combinations is calculated based on whether repetitions of numbers are permitted or not. A factorial, denoted by n, is the product of all positive integers from 1 to n. Factorials are crucial for calculating permutations and combinations. A frequent traveler wants to rank 5 theme parks he visited from best to worst. The number of different ways he can rank them is calculated using factorials. A permutation is an arrangement of n objects in a specific order. The number of permutations is calculated using the permutation formula. The number of different ways to choose a classroom president and vice president from 7 students is calculated using the permutation formula. There are 3 specific female roles for a new television series and 8 applicants. The number of possible ways the casting can be done is calculated using the permutation formula. A combination is a selection of distinct objects without regard to the order. Combinations are used when the order of arrangement is not important. The CEO of a big company has 12 vintage cars and wants to select 5 for exhibition in a car show. The number of ways to select the group is calculated using the combination formula. There are 7 women and 5 men in the arts club. The number of different possibilities to form a selection committee of 3 women and 2 men is calculated using the combination formula.